hi everyone. I'm Alice from House of CK. I'm joined here with Maya from StarkWare. Maya, thank you so much for being here. Very excited to have you.
Thanks for having me.
Yeah, thank you. Wondering if we can first start off with an introduction of yourself. So how did you get involved in the ZK space and join StarkWare?
So I think I first learned about blockchains around 2011, 2012, which is a while ago. Was like mind blown. It was during my undergrad, which was in mathematics. And I was like, okay, this is super interesting. And so I did my undergrad and I did master's in probability theory. And then I was like, okay, where should I go from now? And blockchains were gaining more traction at that point, and it seemed like a really good research direction to go to. So around 2015, I think 16 maybe, I started my PhD, and I was focused on blockchains. And at that time, the focus really was on scale. How do you scale blockchains? How do you make it viable? Have a decentralized system for, at the time, mostly payments. But and how do you scale that and make it secure and decentralized and accessible to anyone? And like, how do you accommodate all that? And at that point in time, people started talking about proving technologies. And around the same time, there started to be a conversation about privacy. And again, this seemed like a use case for ZK proofs. So ZK proofs have been around in computer science for a very long time. And as a mathematician, as a computer scientist, I've always liked this. And people were like aware that this is amazing, but there's no use for it. And then when people started using proving, both in the Zcash world, like for privacy, Monero Zcash came out, and then also StarkWare came out with the scaling, via ZK Rollups. I was like, oh, this is amazing. So I think that's when I first thought about it.
Nice. So you came like from the academic background, so you get from that perspective when you were studying computer science and math, and then came across ZK, and then now joined StarkWare. So yeah, that's really great. Because like a lot of the times we hear different backgrounds of different guests. So there's the background of those who are, say, Web3 natives, but then there's also like academics like yourself who came in this space. So that's really great. And I'm very curious to hear, compared to when you like first got into ZK back when you were doing your PhD, was it? What were the main types of challenges that was in the space at that time that perhaps we have addressed now? And are there any sort of new kinds of challenges that perhaps weren't existent at that time that we're now currently facing? Just wanted to hear your perspective on how the space evolved over the years.
Yeah, so I think it evolved in a way that's unrecognizable. So when I first heard that StarkWare was attempting to build a general purpose, like zero knowledge language, that was like an outrageous statement at the time. Like it was way before I joined StarkWare, by the way. We were like, what? Like, there's no way. No. And they did it. Like, and so the notion that you can now write high level code and compile it, and you get a provable program that's like, you both run it and it's proven, and not to even mention that you do it on the client side, that's like outrageous and so on. So that's kind of crazy. The ZK proofs, when I was first introduced to them, were a thing that you had. You knew that for every statement in NP, you could, like, if you could write a ZK proof. Like, you could have an interactive game, and you can convince the prover, can convince the verifier, and it's all interactive, and like, you can remove the interaction, but still you need to write the circuit, and it wasn't even clear how you go about doing this. You maybe write in C, like, so yeah, or even write the gates, or so the idea is just you just like write high level code and you get a provable program. Is like amazing. So of course the challenges are different. You know, when Zcash came out, people like could not comprehend even what this is. What do you mean it's zero knowledge? What do you mean it's private? now everybody's, clearly everything will be private because we have zero knowledge proofs and you can prove anything that you want. And it's super easy. You just write code and
Yeah. So I think on the developer experience side, especially because you mentioned before, like people originally were just handwriting those circuits, and now people just like regular developers can just write programs and languages they're familiar with, like Rust, like C, and then generate proofs from there. So definitely a lot of strides that were made on that developer experience side. And very curious to hear also about any sort of like, because you mentioned very briefly about some new applications. Any sort of like use cases or applications that you're very optimistic about? And I remember you also mentioned that like before, right now as well, but before the kind of only real focus of zk was towards scaling, and then there's also those PyXZ based use cases as well. So very curious to hear just on your side any that you're very interested in or very optimistic about.
Yeah, so I think blockchains generally came out as a promise to return power to regular people in the world. So at first it was control over your funds, right? You have complete control over your money. So today, still, people don't have ownership of their funds, like the funds are in bank. So blockchains solved this problem. But then there was the immediate problem of privacy, right? So I own all my funds, everybody knows what I'm doing. Everyone in the world can film everything that I'm doing. So clearly a use case for ZK improving is solving this. But this is easy, right? And then the next pretty obvious layer is everything that has to do with ZK identity, right? So every time that you have to do KYC for a website and you have to scan your passport and then scan your face and send all this data in clear text to someone, that's outrageous. And it leaks all the time, and also your credit data leaks and everything leaks. And nobody should have this data. Like we have the technology, like ZK technology, client-side proving technology can just make it so that you just never have to send this information out. You can prove that you have a valid passport of a country and that you are over this age and that you have been here or there, and that even this is not the passport that you stole because you scan your face using some trusted execution environment and everything matches, and you prove this on your phone and it's trusted and it's verified, and you prove it and you send it out and nobody knows who you are even. That's amazing. So, but that's clear, right? But there's less clear use cases for proving on the client side that I think people, when you focus too much on the privacy and the ZK aspect of things, you lose like just obvious use cases. Like right now, I was mentioning this before, but suppose you have an IoT device at home, right? So you have the smart doorbell, the camera. Yeah, where do these images go? They're stored with some cloud. You don't know who runs this cloud. You don't know. If people see every time you enter your home, and not to mention if you have security cameras all around or cameras in your own home because you want to look at your dog, and you have a smart lock with a fingerprint, like you don't know anything about this. And it's like so useful that you give up your privacy, right? Because everybody has IoT devices. It's not like people say, okay, no, I'm a privacy freak, so I'm giving up all the conveniences. This is not true. So right now you're at this point that people talk about financial data, but this is like your entire life.
Right in front of us, yeah.
So you can use easily ZK proving technology to prove, like to have a component on an IoT device that proves that it's only communicating with your phone, with your IP address. Nobody else has access to your data. Like this is a super easy circuit to write, right? And it doesn't have even to be ZK. It's not a ZK application, it's just a proving application. Just prove that that the information doesn't go anywhere than physically you. So that's like, and IoT devices are super hackable. Yeah. So I think that's like an obvious thing that must happen with this ZK proving.
Yeah, absolutely. And I really like how you mentioned those kind of applications outside of this Web3 space. Because as you mentioned, like so much focus is being put on, say, like, for example, securing transactions. But there's these very obvious use cases with, like, for example, those monitoring cameras, was ring bells, even those like baby monitors. We don't know where all of that footage is going. And these are just like systems that we have to interact with every day. And these are, and not using them it's just like not an option for a lot of people. As you mentioned, we have to give up our privacy in order to use these technologies, which is not really fair. So really great that you mentioned all of those points.
I think especially that like today, AI models learn video footage, and there's like you say, okay, there's not that much video footage of me, so how will someone learn about me? But then they can just like have unlimited access to video of you.
Yeah, exactly. And even the generation of deepfakes as well. That's a big problem for a lot of people because that's not actually them. And a lot of scammers are trying to take advantage of that as well. So perhaps even we can have like a proof be generated to see if that picture is like a legitimate picture or if it's just like AI generated. So lots of different applications, especially as we're going into this new age. Yeah, definitely. And I'm very curious to hear some more details about some developments made on the StarkWare side as well. So I know that StarkWare, like relatively recently, has started transitioning from using the Stone Prover to Stew. So I wanted to hear some more details about first the differences between those two types of provers, and also the motivations for StarkWare kind of developing its own prover system, and what on the user side, what users can expect with this transition.
Yeah, so Stone is our legacy prover. It's the original zk prover, like general rule. There was no other one beforehand. So when StarkWare originally developed it, there was no RISC-V, no RISC-V. Like so there was Snark technology and Stark technology, and Aztec went the Snark way. And StarkWare went the Stark way. Elie Winston, the founder, he also invented Stark. So it was an obvious choice. There's no trusted setup, post-quantum secure. And so Stone is a Stark-based prover, and it was the first one, and it's based on a large field. It operates over a large field. And this was great. It worked. And Starknet is based on it, and it runs, and it's efficient. And it scales Ethereum incredibly, and I think we had consistent like 100 TPS over I don't know how many blocks, and that's incredible, and that's with the Stone prover. But since then there's been a lot of advancement in the proving field, and people in recent years have been talking about how provers would likely be much more efficient over small fields, finite fields. So. And the challenge has always been to find a small field that would be prover-friendly in the sense that you would also have a large multiplicative subgroup in that field. And that was non-trivial to find, and it was a StarkWare development to find the Mersenne field 31 and 31, which has a large multiplicative subgroup, which is not the trivial group that is derived from the field, but the circle group. Okay, so the unit circle. And apparently, which is the thing that is even more surprising, is that the circle multiplicative group, the unity circle over the Mersenne field, has nice properties for Fry and everything that you need for proving to be efficient. So then we decided StarkWare to develop this two prover, StarkNet 2, so Stone StarkNet 1 to StarkNet 2 prover, and it's based on Circle Starks. And it's just much more performant. I believe that it proves a trace cell 1,000 times faster than Stone. So you have to be careful because the trace cells are a little bit smaller than the ones in Stone. But it's still at least 150x faster than Stone. And there was non-trivial work to make Stew work over StarkNet, because StarkNet, as I said, there is the Stone prover that works with the Cairo VM, which compiles code to Chasm, which is then proven with the Stone prover, after being translated to polynomials aside. And the Cairo language is compatible with Cairo VM and is optimized for Stone, so over the large field. So it's non-trivial to get things to be efficient with Stew over the large field, because Stew is optimized for small field. So we had to write errors that basically simulate the operations in the large field in the small field for Stew. So that's a lot of integration work that had to be done when writing the errors for Cairo for StarkNet for Stew. But stew as a standalone is optimized for small food. So we are working now with the Cairo team to redesign the Cairo VM, rewrite brand new errors for stew for the small Cairo, to have a super, super fast client-side stew version. So you would have a Cairo-like language. It wouldn't be exactly Cairo, but be a subset of Cairo, 0 probably. And you could write your applications in Cairo and you run them locally and you prove them locally with stew. And it will be even 50x, hopefully faster than stew today with Cairo, which beats all benchmarks. So hopefully it will be compatible with small end user devices to accommodate all of these use cases that require weak hardware. So if you have an IoT device, you have a weak hardware. If you have an iPhone, it's not weak, but it's not strong.
Right.
Yeah, but so we're fully optimizing stew now for client side.
Nice. And yeah, I really like how you mentioned that because, with client-side proofing also comes like the consideration that consumer hardware has to be used, and those are like typically those weaker devices. And then there's also some developments being made on like mobile side proving. And yeah, it's really great to see just all of these developments being made and in turn making proving more accessible for a larger number of devices, also a larger number of people. So yeah, really, really exciting to see all of those developments being made there. And in terms of other kind of like relatively recent developments on the StarkWare side, I know that StarkWare has released its own zkVM, the Stark 5 zkVM. So wanted to hear some more like details about it, some of the design considerations that the team has made around it. So I know, for example, the ISA you chose was RISC-V, and then you had some other kinds of design considerations there. And then also just the motivation for the StarkWare team kind of building its own zkVM. I mean, right now, like there's quite a lot in the market, and we're all trying to reach towards real-time proving. So wanted to hear some more about like the motivations and also design considerations.
Yeah, so I want to say we didn't release the RISC-V zkVM. We have a zkVM. It's the Cairo zkVM,
Mm-hmm.
the original zkVM,
Right.
and it's the official zkVM that we use at StarkWare for StarkNet, and like that's our stack. We are working on the Stark 5 project, which is more of a POC project for us at the moment, where we want to write errors for stew for RISC-V. There's another team doing this, Nexus, so we will work hopefully in collaboration with them to not do duplicate work. But the idea there is to see whether clearly people want to write code in Rust, and we, as StarkWare, have always said that proving Rust and proving RISC-V will be always slower than a dedicated optimized zkVM. So, but we also realize that maybe end users and developers especially don't care about it, and they want to have the ease of writing Rust and prove it like client-side proof efficiently. So we are dedicated to we're doing research on what it would take to write errors for RISC-V for stew, and if we see this is viable in terms of whether it will actually be, in our opinion, usable for end users in the foreseeable future, then we'll pursue this and implement it as a product. So we're not committing to this as a full-blown StarkWare project, but we are working on it. It's also important for us internally to see how good this can be, because there's been some conversation going on about how to properly benchmark zkVMs. And we have invested a lot of time and effort into properly benchmarking stew against competition. But we would also like to benchmark stew with Cairo versus stew with Rust to RISC-V, just to see how much you lose if you write, because we know that we write good errors for RISC-V for stew. Like we're an experienced team, we can do it properly, and so it would be a fair comparison of optimized RISC-V errors versus optimized Cairo VM errors. So we really want to know this.
Yeah, and it's really great to hear that you're also really keen on those benchmarking standards as well and testing those different kinds of scenarios. I feel like a lot of kind of ZK teams, zkVM teams are also looking to see how they can benchmark appropriately and compare that to those industry standards. So really great that there's considerations there as well. And then just when we, now that like we have many of, say, for example, these zkVMs trying to work towards real-time proving, was wondering just from your side, once we get there, I mean, some zkVM teams have already claimed that we reached like that proving within the 12-second slot. But just when we reach that stage and it becomes accessible for more people, wanted to hear from your side what kinds of either new applications or any kinds of predictions that you have that can be enabled with real-time proving.
Yeah, so the real-time proving with theory of blocks, this race, it's not really what StarkWare is focused on. So the Cairo team are representing the Cairo VM in that race. I believe they'll win that race, but I don't know how meaningful those benchmarks are currently, because first of all, if you need the $250,000 GPU setup, $500,000 GPU setup to prove an Ethereum block in real time, and I don't really know how you parallelize that when you do it. Like, is it a true, like, I don't know. I don't know how meaningful it is. If it were done on an M3, like, or an iPad, then that would be meaningful. To me, I think the race is good because it drives the field forward. I don't like that it's overfitting to. It's like all AI models are overfit to the same data set. So I don't like that all zkVMs are being like super tailored to proving the EVM, because I don't. First of all, because truly, if Ethereum is going to enshrine one zkVM into their stack, like all others will lose. And if they optimize only for this, then they miss out on the race to prove like other things that are useful in the world, and they can optimize their, like, spend their effort to optimize for. But it is good that it's driving the field forward and bringing this topic of proving to the public. And benchmarking is important, so it's a benchmark. I do like, it's kind of a parallel effort to what we're doing at StarkWare, but we again like that it's driving the technology forward.
Mm-hmm. Yeah, I see. Yeah, and it's really great that you mentioned kind of first, we don't want to just optimize for, say, proving Ethereum blocks, and if we, as you say, go towards a direction where we're only going to enshrine one zkVM, then how about the developments of the others and any other sort of applications that zkVMs can provide for us? So yeah, really, really great that there's that consideration, and also the fact that like the question, have we really reached real-time proving if you need like a cluster of 200 GPUs in order to get that proving time down low enough? So yeah, these are all really great considerations to think about. And just on any kinds of like new types of developments coming up in the StarkWare roadmap, or any announcements that you'd like to make to developers, users in the audience, of how they can get more involved?
Yeah, so first of all, there's this 2 version alpha out for client-side proving, so you can play around with it. 2 is completely open source anyway, so you can even write the errors for 2. So we're super happy for people to try it out and give us feedback so we can improve. This is not the final client-side version. As I said, we're rewriting the VM, and the errors and everything will be much, much, much faster, hopefully. But you can still start working now to understand the tech and play around with it. As far as announcements, we are planning to make Stu ZK. So it will be a ZK start prover, which they typically are called ZK or they're not. So we're very excited about that for all client-side proving purposes for privacy. And of course, the new client-side proving version of Stu that we're working on is super exciting.
Yeah, nice. Lots of new developments coming up. Yeah, very exciting. Thank you so much, Maya, for being here.
Thanks for having me.
Thank you.